Hello everyone, welcome back to the channel. This is the third video in the series of AC circuits. Previously, I had posted a video on the fundamentals of AC circuits where I had shown you how to obtain the average and RMS value of any waveform. If you haven't checked that video, the link is provided in the description box. In this video, I will solve the problems of RL series circuit. I had covered it in the basics already. The link for the same video is also available in the description box. In AC series circuits, we express the impedance as R plus J XL, which is also written as J angle theta, where magnitude of Z is R square plus XL square under root, and theta is tan inverse XL by R. And in case of RL series circuits, current I is taken as reference. Voltage across the resistance is in same phase. Voltage across the inductor leads the current by 90 degree, and the resultant voltage is algebraic sum of two voltages, that is voltage across the inductor and voltage across the resistance, and this angle is denoted by theta or phi, which is known as power factor angle. And power factor cos of theta or cos of phi is given as R by Z, and its lagging power factor in case of RL series circuit. Now let's start with the numerical problems. I am not going in too much detail of RL series circuits. The first problem is, when an inductive coil connected to a DC supply at 240 volt, the current in it is 16 ampere. So what is given? We have a DC source, then voltage is 240 volt and current is 16 amperes. When the same coil is connected to an AC supply at 240 volt, the current in is 12.27. Now when the source is AC source, voltage is same 240 but current is different, it's 12.27 amperes. Calculate the resistance, impedance, reactance and inductance of the coil. So an inductive coil means basically a RL series circuit. And here we have the source, which can be AC or DC. So when it's a DC source, at that time inductor behaves as short circuit. Now why short circuit? Because DC has the frequency is 0 and XL is 0. So the current is basically flowing through resistance only. So R is V DC by IDC, we can say. We write this as VTC and this as IDC. This is VAC and this is IAC. Now DC and AC, they are just added to differentiate them, that when it's a DC supply or an AC supply. So R is 240 by 16, it's 15 ohm. Resistance is 15 ohm, and from AC what will we get? We will get the impedance. So Z will be voltage, AC voltage upon RMS value of AC current, 240 by 12.27, which gives us the impedance as 19.56. Also we know that in case of RL series circuit, Z square is equal to R square plus XL square. Now we have the value of Z, we have the value of R. We can calculate XL as under root Z square minus R square, 19.56 square minus 15 square whole under root. So which gives us the value of XL as 12.55 ohm. But the question is, we have to find the inductance as well. We also know that XL is equal to 2 pi FL. So L is equal to XL by 2 pi FL. Frequency is given. It's 50 hertz. 2 pi into 50. Sorry, not L over here. 2 pi into 50, which gives us the value of inductance as 0.0399 Henry. So this is how we get the value of resistance, inductance, impedance and the reactance. So all these were asked. Reactance, this is the impedance, resistance over here. Now the next problem is a load of 22 kilowatt operates at 0.8 lagging power factor. Now when it's written 0.8 lagging power factor, it means it indicates that load is inductive load. It's an inductive load, means RL, inductive load, is connected to 420 50 hertz single phase source. So voltage is 420, frequency is 50 hertz. Find current, and power is also given, that is 22 kilowatt. Find current, power factor, angle, impedance, resistance. Now we know that in case of AC circuits, power is VI cos phi. Cos phi is also given, it's 0.8 lagging power factor. Power is 22 into 10 raised to power 3. Voltage is 420 into I into 0.8. From here we will have the value of current as 65.48 amperes. This was the first part, part A. You can say part A starts from here. Then part B is power factor angle. We have the power factor, so power factor angle phi will be cos inverse 0.8, which is actually 36.87 degrees. Then we have to find out the impedance. We have the value of current, we have the value of voltage, so we can calculate the impedance. Part C is impedance, which is V upon I, 420 upon 65.48. So impedance is 6.415 ohm. The next part is resistance of the load. Now how to find out resistance? Resistance can be found by using different formulas. We have one choice, that we can calculate R as Z cos phi. 6.415 into 0.8. So this will give us the value of resistance at 5.132 ohm. Another choice is we can find out the resistance from the power, that is I square R, 22 kilowatt, and then we can use the value of current. You will get the value of R as same, that you can verify. In the next part, we have to calculate the reactance. Once we have the value of impedance, resistance, then we can calculate the reactance XL as Z square minus R square. Z is 6.415, R is 5.132, square under root. So this will give us the value of XL as 3.85 ohm. You can also find out the value of XL as Z sin phi, 6.45415 into sin phi. You will get over here as zero point 0.6 and you will get the same answer 3.85. So you have different choices, so you can find out it either way. Then next part is we have to find out the voltage and current equation in the form of instantaneous values. Now for instantaneous values, how we write? We write V is equal to Vm sine omega t. Now what is omega? Omega is 2 pi f, 2 pi into frequency 50, 340, 14. We have RMS value of voltage as 420. So V max will be equal to root 2 into Vrms. So root 2 into 420. So that will give us the value of Vm as 593.97 volts. So instantaneous value of voltage is 593.97 sine 314 t. Similarly, current is I max sine omega t. Now this is an RL circuit. We have lagging power factor. It means current is lagging behind the voltage. So it's sine omega t minus phi. Im is I into root 2 I we found as 65.48 into root 2. So this is actually 92.6. So instantaneous value of current is 92.6 sine omega t is 314 t minus phi is 36.87 degrees. Amperes, and with voltage we have to write the voltage. So this is the equation for instantaneous voltage, while this is the equation for instantaneous current in the circuit. Now the next question here is, a choke coil is connected in series with a fixed resistor. Now what we mean by choke coil? Choke coil means a pure inductor in series with a resistance. So basically we can say it's a RL series combination. So this is a choke coil. Let's say the resistance is denoted by RL, inductance is L. It is connected in series with a fixed resistor, that is R. Now this one is actually choke coil. Now the combination is connected to 240 volt 50 hertz supply. So here we have a voltage source, an AC voltage source, 240 volt 50 hertz, and a current of 2.5 ampere flows through it. So current is 2.5 ampere. 240 volts, 2.5 ampere, these are the RMS values. If the voltage drop across the coil and fixed resistor is 140 volt and 160 volt respectively. So voltage across a choke coil is 140 volt and across the resistance is 160. Calculate the value of fixed resistance and inductance of the choke coil, and also we need to calculate the power drawn by the choke coil. So we have the value of current, we have the value of VR 160 volts, we have the value of VL 140 volt, we have V as well 240 volt, current is 2.5 ampere. First thing we can calculate from here is the resistance of the fixed resistor, which will be VR by I, 160 by 2.5. So R will be 64 ohms. This is the first thing which we calculate from here. Then from the voltage across the choke coil, now a choke coil is actually a series combination of resistance and the inductor. So basically this voltage divided by this current will give us the impedance of the choke coil. Let's say the impedance of choke coil is denoted by ZL, and it will be VL by I. ZL is 140, I is 2.5, so ZL is 56 ohm. Also we know that this ZL is equal to RL square plus XL square under root. This is equal to 56. So what we get, that RL square plus XL square is equals to 56 square, or RL square plus XL square is equal to 3136. So this will be our first equation which we need to use. Now we have one equation, two unknowns, so we need one more equation so that we can have the solution. From where can we have that equation? That equation can be obtained by using the supply voltage and the current drawn by this whole circuit. So when we divide this 240 by 2.5, this will give us the impedance of this whole RL series circuit. So Z will be equal to V upon I. V is 240, I is 2.5, and Z is equal to actually RL plus R square plus XL square under root. That is the impedance of whole circuit. So what we get? This one is 96 ohms. That RL plus R square plus XL square under root is equal to 96, or RL plus R square plus XL square equal to 9216. Now we have the value of R. We had already calculated the value of R as 64. When we substitute that value of R over here, then we can obtain the second equation, which will have again same unknowns as equation 1. Now when we solve this equation, the simplified equation will be RL square plus 120 RL plus XL square is equal to 5120. So this one is our second equation, and this was our first equation. Now if we subtract first equation from the second equation, then what we have? RL square plus 120 RL plus XL square is equal to 5120. First equation is RL square plus XL square is equal to 3136. Now if we subtract this, we can get the value of RL, and that is 15.5 ohm. This is what we get from the solution of these two equations, first and second equation. Now once we have the value of RL, then we can calculate XL from here. Now XL is equals to under root 3136 minus RL square, 3136 minus 15.5 square, which will give us the value of XL as 53.812 ohm. The next thing we need to calculate the inductance. Once we have XL, then XL is equal to 2 pi FL. We have the value of frequency, we have XL. This gives us the value of L as 0.171 Henry. And the last part is we have to calculate the power consumed by the choke coil. Now power consumed by the choke coil is current square, now current through the choke coil into the resistance of the choke coil. Current through the whole circuit is same since it's a series circuit. 2.5 square into RL is 15.5. So power consumed in choke coil is 96.875 watt. And the last question in this video is, in a series circuit containing resistance and inductance, the current and voltage are expressed like this. So these are the instantaneous values. What is the impedance of circuit? What are the values of resistance, inductance and power factor? And what is the average power drawn by the circuit? So the instantaneous value I of t is 5 sine 314t plus 2 pi by 3. Then voltage Vt is 20 sine 314 t plus 5 pi by 6. Now we need to calculate impedance. What is impedance? Impedance is RMS value of voltage upon RMS value of current. Vmax by root 2, Imax by root 2. Now this one is representation of Vmax sine omega t plus phi 1, and this one is actually Imax sine omega t plus phi 2. So Vmax is 20, Imax is 5, which gives us the value of Z as 4 ohm. Also we need to calculate the phase difference between the voltage and current, so that will give us the power factor. You can say phase angle phi, that will be equal to phi 2 minus phi 1. Phi 2 is 150, phi 1 is 120, so this is 30 degrees. So current lags behind the voltage by 30 degree. We can say if voltage is Vm, so not Vm, if we want to express the voltage in phasor form, the RMS value voltage is Vm by root 2 and angle is 150. So Vm by root 2, 20 by root 2 and angle is 150 degree volts. Similarly current, RMS value of current is in polar form, it's Im by root 2 and angle is 120. So I is 5 by root 2, angle is 120. So in polar form, impedance is 20 by root 2 angle 150 upon 5 by root 2 angle 120. So it's basically 4 angle 30 degree. Now if we change this in the rectangular form with the use of calculator, or you can write it as cos 30 plus 4j, j4 sin 30. So this one is 3.464 plus j2. This real part denotes a resistance 3.464 ohm. Imaginary part denotes a reactance, XL is 2 ohm. XL is 2 pi FL. So L is XL upon 2 pi F. This omega has value 314. Omega is 2 pi F. So XL 2 divided by 314 gives the value of inductance as 6.37 millihenry. And the last part in the question was we have to calculate the power factor. Power factor is cos 30, which is actually 0.866. Power is VI cos phi 20 by root 2 pi by root 2 into cos 30 43.3 watt. In the next video, I will take the examples of RC series circuit. If you consider the content on this channel useful to use, please consider subscribing the channel. Thanks for watching the video.